Welcome to the Spring Semester 2018 Review Part 3. Alright, let's look at what we've got here. So, we're starting at 42, and we got to remember these are all simplified, so we want to be able to do a factor tree if need be. They're going to start us off with, surprisingly, some stuff easy, so where you could easily take the square root and then just kind of go from there. But let's look at, say, 42. Square root of 25, x to the 20th, y to the 14th. Now, I taught y'all, okay, obviously factor tree, the only thing that goes in 25 is 5 and 5, so I got a pair of 5s that goes on the outside. I have nothing left over. And then I would tell you, write, x 20 times or write y 14 times. Actually, I don't think I ever went that high because I'm not that crazy. But a simple shortcut is if you can divide the exponent by the index, which in this case would be 2, 20 divided by 2 would give you 10. 14 divided by 2 would give you 7. So if they divide evenly, it's easy peasy. Let's see here. 43, same thing. Square root of 36 is 6. Divide the 10 by 2 and you get 5. Divide the 6 by 2 and you get 3. 44, you take the square root of 144. So, and if you want to do the numbers, just type them in the calculator and see if they come out even. If you don't have your perfect squares table written down on your note card. But the square root of 144 is 12. 12 divided by 2 is 6. 20 divided by 2 is 10. 45, same thing. Square root of 169 is 13. 8 divided by 2 is 4. And 4 divided by 2 is 2. Okay, so now on the next one, we got to be a little bit more careful because we're now looking for the fourth root. So on the calculator, again, that should be like the control and then like the square root button or the index button that gives you say an index with like a number here and the number there. So you can put in the fourth root. If you don't, you could do a factor tree. You're looking for groups of 4. Now, the nice part is this fourth root of 81 is 3. So it looks like they're trying to keep it simple here, amazingly enough. And then, look, if you take the exponents and divide them by the index, in other words, 32 divided by 4, you'll get how many groups of 4 you get here, 8 and then 5. So we're kind of shortcutting this a little bit, trying to make it a little bit easier. Same thing here, and all I'm doing is dividing by 4 on the exponents. Okay, so now I get to some that don't simplify nice and easy. Okay, so here I would break it up and say, okay, 98 is divisible by 2, that gives me 49. 49 breaks up to 7 to 7. So I have a pair of 7s with a 2 left over. And then the next part here would tell me that I've got 23 x's. Again, if I write those out, I could, but I know x divided by 2, or 23 divided by 2 would go 11 times with 1 left over. And then 24 divided by 2 gives me 12, and there I go. So I don't necessarily have to always write them out and pair them up, but I could. I could have gone 23 x's and found all my pairs. I was just being a little bit lazy there. Anyways, let's look at another one. Number 49, same thing. You divide the 50 by 2, you get 2 and 25. 25 would be 5 and 5. So I've got a pair of 5s that can go on the outside, and I have a 2 that stays on the inside. Then for the x's, 11. Okay, so on the x's, keep in mind that 11, I can make 5 pairs with 1 x left over. On the y24, 24 divided by 2 is 12, and so there you go. And again, you could write those out and do 11 x's and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And I can see I've got 1, 2, 3, 4, 5 pairs with 1 left over. Okay. Number 50, we're going to say, we got to make sure before we can add them or subtract them, they have to have the same number under the radical. So if you have 245, 20, and 45, technically you supposedly can add them. But let's break it up. 245 is divisible by 5, gives me 5 and 49. And then 49 is 7 and 7. So that means I have a pair of 7s that go on the outside with a 5 left over on the inside. Here, 20 is 5 and 4. 4 breaks up to 2 and 2, so I have 2 with a 5 left inside. And then finally, I have 5 and 9 with a pair of 3s that go on the outside. So notice how I rewrote them to say 7 square root of 5, 2 square root of 5, 3 square root of 5, with the pairs going outside and the leftover staying inside. And now that they have the same number under the radical, I can go ahead and add and subtract. So 7 plus 2 is 9, and 9 minus 3 is 6. So the answer there was 6 square root of 5. Oops. Okay, so here we go with 51. Same thing. Ah, good grief. Okay, so I'm going to let 51 play out, but it's basically the same thing. Notice here that I'm dividing it up. First one ended up being 7 square root of 2. The second one, okay, notice here I stopped at 6 because I had a pair of 6s with a 6 left over, and 6 is just 2 and 3. So technically I can stop when I see a pair, like here, and that goes on the outside. This 2 and this 3 would have combined again to go back to become a 6, so that had a 2 and a 3 left over. Here I've got 2, 4, that's 2, 2, which would be 2 square root of 2, and then finally 9 and 6, pair of 9s, pair of 3s, and then a 2 and a 3 left over to give me 3 square root of 6, and then combine your like terms. So final answer here would be 9 square root of 2 minus 3 square root of 6. And there you go. Alright, for 52 and 53, you could do box method or distributive property or even vertical. First one I'm going to do is by box method, and then I'll do another one with distributive property. So y'all kind of remember this. 2 times 4 is 8. 4 square root of 3 you can do nothing with, so you just put 4 square root of 3. 2 times negative square root of 7 would be 2, negative 2 square root of 7. Notice how I just put the negative in the front, or the minus, whatever. And then square root of 7 times square root of 3, because they're both under square roots, then I can multiply and say square root of negative 21. Notice how there's a minus in front. Put everything together. There's nothing you can combine, nothing you can do with it. You're done. Bada bing, bada boom, done. No worries. Hopefully they don't throw you a curveball. That would be mean. Anyways, number 53 is by the distribution method. Thank you. You can see here I'm putting 4 times 6 minus square root of 3, and then square root of 7 times 6 minus square root of 3, and then I'm multiplying. And pretty much everything's all laid out. Once I'm done, that's it. That you can't do anything else with that, and you're done. So there you go. Yay! That was easy. I can do that. Alright, so let's look at solving. When you have to solve, remember, get everything that's outside the square root done first, then you can square to get rid of the square root. So, like on this one, I need to say, get rid of the 3, so the plus 3 I'm going to subtract. Notice I'm just going from the left to the right, and say 11 minus 3 is 8. So then I can square this. That gets rid of the square root and leaves me with just the 5x minus 1 equals 8 squared, which is 64. Then I can add and divide, and I got my answer. Bam and bam. Simple, easy peasy, kind of go from there. Number 55, same thing. I'm going to subtract 10, and then I'm going to try to take the, try to square it. But notice here, when I say 3 minus 10, I get a negative 7. If the step right before you're ready to square it, like right here, right now where I'm ready to square it, and you have it equal to a negative number, there's no solution, because you're saying that I subtracted some number by 1 and then took the square root, and when I took the square root, I got a negative 7. It is impossible to take a square root and get a negative answer as such. So, like, there is no number that squared would give you a negative number, in other words. So here we will say no solution. Okay, and if you were to solve that out, you would get 49 plus 150. I mean, you could put it in there and you would discover it would give you just a slightly different answer. Let's see here, it would give you, like, say 17. So instead of getting 3, we would end up getting like 17. And so it wouldn't match. So it wouldn't have checked out. So just keep in mind, if right before you take your square root, you get a negative number, or I'm sorry, before you're ready to square it to get rid of the square root, you have a negative number, then there's going to be no solution. Alright, 56, I'm going to subtract 1. So 5 minus 1 is 4. Then I square it. That gives me 4 squared is 16. And then 16 plus 1 is 17. And 17 divided by 6 is 17 divided by 6. So nothing else I can do with that. All done. Easy peasy type of thing. Okay, 57, same thing. I'm going to say subtract 2. And then I'm going to say square that. So 12 minus 2 is 10. Then I can square it. 10 squared is 100. Then I can add 7 and divide by 8. And again, it kind of just keeps getting easier and easier from there. So really no different. Your final answer is 107 over 8. Let's look at the next one, 58. I'm just going to let these keep playing. 57, wait, what am I on? 58, I'm going to subtract 5. And then I'm going to say square that, get 196, divide by, subtract 6, and then divide by 8. And that one simplifies a little bit differently. 190 divided by 8 ends up being like 95 over 4. And there we go. And then let's look at 59. 59, I can say subtract 8, and then that 20 minus 8 would be 12, and then square that. That would give me 144. I would subtract 7, and then divide by 4. You can see these basically play out basically the same way. Not much you can do there. Alright, so now, and notice a lot of these come out with fractions. You're probably going to end up with fraction answers. You'll live. It's not that bad. So there we go with that final one for the square roots, and we'll move on to the next part.